Hello there folks. In this video we're gonna go through some bitwise operations, specifically managing flags. What I mean by managing flags, you use a binary representation of an integer to record on-off stage of multiple flags. So if the bit error position is 1, then it's on. If it's 0, then it's off. That kind of thing. So to turn on flags, you do this operation over here. So this is equal to flags is equal to flags or bitwise or, and the right hand side. Okay, the right hand side here is 1 left shifted by this much. Okay, so this is the exact example code. So it says here, the comment says turn on flags at bits to check from sensors. Condition only turn on bit if the sensor is turned on. So the sensor is represented by this binary over here. So it's 8-bit binary number, and each bit represents separate sensors. Okay, so bit over here is 1, so it means that sensor represented here is turned on, or this one, sensor represented here is turned off because it's 0. And we're gonna have positions to check. So these are the positions to check the sensor status, and these positions are counted from 0. So least significant bit, the rightmost bit is 0, the next one is 1, 2, 3, and so on. Okay, so idea here is we're gonna check the sensor status at these positions, 4 positions, and if the sensor is on at that position, then we're gonna reflect that on our flags. Okay, what we're doing here is that in C we don't really have built-in way of getting the size of our arrays. So here we're just getting the size of our arrays, array bits to check, which is 4. Okay, there are four elements which are 4 bits to check the sensor status for. Okay, so in this for loop over here, we're just going through each bit to check. Okay, and this is a bitwise trick that gives you the value of the bit at position. Okay, so for example, I told you this for loop is going through each of the element over here. So the first one is 2, so we check the sensor status 0, 1, 2. You can see the bit at that position is 1. So okay, saying if only if the sensor at that position is turned on, which means it's 1, then we reflect that in our flags. Okay, so what this does, okay, this is what I told you at the beginning, this trick over here. It will turn on the flag at that position. Remember, we started with 0. Okay, so that means it's 0 filled to 8 bits. okay, because it's unsigned int 8-bit type. So we started with 0, 0, 0, 0, 0, 0, 0, 0, you could say, and whenever the bit from sensor status at the bits to check are turned on, we turn on flags at that position, okay? So this is just printing the result of sensor status and flags. So we started with sensor having this value, okay? Let me just run it, okay? And you'll see what I mean. Okay, let's run it. Okay, so this is what happens. So we're gonna check position 2 first. That's the third bit from the right. Okay, it's 1. So you put 1 over here on the flags, okay? 3 is also 1, so 1 over there. 5 is also 1, and the 7 is also 1. Okay, so in effect, every bit position from sensor status that are already turned on, we selected those positions as bits to check. So we just inherit the information from sensor status and gives it to flags, okay? So it's copying it in effect, but doesn't have to. Okay, for example, at position 3, say 0, 1, 2, 3, if this bit was 0 over here, then this check will fail, right? This one over here. Therefore, flag will stay 0 at that position. Okay, so this is how you can use bitwise operations to turn on bits that represents a collection of flags, okay? Which is very cool. Now, conversely, we could turn off flags. We use this trick over here to do that. Okay? Let me just copy and paste this. I'll just modify the previous code. So there's not much to explain. So this time we're gonna turn off flags at bits to check from sensors. The condition here is different from the last one because it's a converse operation. Only turn it off if the sensor is turned on, okay? So this time we're gonna, we have the sensor status over here, okay, and we got our pre-existing flags. Previously we initialized it with 0, but in this case we need something to work with, so I just put everything as every bit position as 1. That's our flags, okay, that we work with here. And the bits to check are first 4 digits from counting from the right, okay? So this one, and this one. These are what 0, 1, 2, 3. These are the bits to check. And the structure of the code is almost the same except for turning off logic over here. So basically we're gonna check the first 4 digits from the right. If the bit is 0 here from the sensor status, then we do nothing, okay? Only if the bit value is 1, then we turn off the flag at that position from flags variable, okay? So if we jump to the conclusion, jump to the result, we're gonna I'm reminding you that we're gonna check the first 4 digits from the right. Okay, the first digit is 0, so we don't turn that off. Second, 0, so we don't turn it off. Third and fourth are 1, so we turn those off. Okay, so let me run it. As you can see, only these 2 bits are turned off, which is expected, okay? Because we're gonna check the first 4 digits from the right. only third and fourth digits were turned on, therefore we turn off those digits. Okay, and the logic that does it is this one over here, which we introduced. Okay, let me go back. So what these are, this is equal to flags bitwise and the right hand side. The right hand side means this is bitwise not. We are applying that to inside the parentheses, which we previously learned, which is 1 left shifted by this amount. Okay, so this is how you can use the bitwise operations to turn specific flag on and off using the flags variable, which is a unsigned 8-bit integer in this case. Okay, thanks very much. See you next time.